Good afternoon, dear students. Welcome to Introduction to Data Structures and Algorithms class. Today's agenda is all about functions and its type and examples on function-based programs. And we'll discuss about arrays at the end. And let me understand what is the need of function. In fact, function is nothing but it's a subprogram. It's a set of instructions. So just like a program, it is a subprogram. What is the importance? Whenever your program becomes too big, it becomes very difficult for anyone to manage. So what happens? This particular concept of functions will give completely an independent logical component which is leads to modular programming, module by module, group by group. You can have the program and you can execute the program. And remember one thing, we all knowingly or unknowingly, we are all using main function. Main function already we are using. So this is the program, this is the starting point where your C program gets executed. And you can also write your own user defined programs. So many programs you can have. So these programs you can certainly execute. That is what this is all about. And of course, importance of function. So when program becomes too large and complex, as a result, the debugging is nothing but the error checking, error correction, maintaining of program becomes very difficult. So if the program is divided into smaller functional parts, then uh, each part may be independently coded, and of course finally they are combined, so which is what you call it as divide and conquer. So solving a big program, solving uh, a difficult program, and of course it is very difficult. Instead, what you do, you divide the program into smaller programs. You call it as functions, and you try to conquer the solution one after the other, one after the other, and finally what happens, your function becomes complete solution. Your entire functions becomes complete solution. You combine them, so that is what we call it as divide and conquer. This is one of the very popular technique that is being followed in programming, and that is achieved through this functions. Advantages, if I tell you advantages, reusability. If you write a function and store it in one library file or header file, it can be used by multiple programs. It can be used by multiple, in the program itself, multiple instances, multiple cases, you can use it. So code becomes reusable. Instead of writing every time the same code, what you can do, you can reuse the same code. So first advantage is reusability. Second one is debugging becomes easier. So you will easily understand the error is present in only this function. Oh, you will understand, oh, there is, if I tackle this function, I can easily rectify the error. So I can easily write, I can easily correct, rectify the error. And you can write many functions of your own and build your own library. So that is also advantage. So there is also an advantage, and of course you will get own library function, you can create it and you can develop it. So today, most of the organizations, they are contributing programs like this. They are contributing to the program community like this. They write their own library functions and they'll give it to release it and give it to the community so that they can use it. That is the biggest advantage that one can expect from functions. Now, look at this particular example. It is actually a multi-function program. Observe now, there are two types of functions. One is printf, another one is message. And remember, message is redefined here. Message is redefined here. That means you're given a clear definition what it has to be done in the message. But printf, it is a already built-in function. Printf is already a built-in function, which is there in your stdio.h. stdio.h is already there in stdio.h. So it is a built-in function. This is user-defined function. So in a multi-function program, you will have multiple functions. One is built-in function. All built-in functions are available in the header files. And user-defined functions are defined by the user. User-defined functions are defined by the user. So this is one of the very important concept that you should understand. Built-in functions are available inside the header files, and a user can also define his function using a technique, that is user-defined function technique. He can do it. So he can define, he can also write programs, he can also define his own function. Let us see how to write user-defined functions and how to define it. So whenever we look into this concept, there are two components come into picture. One is whenever you want to define your own function, whenever you want to define your own function, what happens? You need a name of the function. Normally, name of the function here, look at here, this is sum is nothing but it's a name of the function. And body of the function. Body of the function is normally written within curly braces as a compound statement, body of the function. Next, parameter list. Parameter list means what are the variables that are being passed from main function to user defined function. So these are the values, x value and y value are passed from main function to the user defined function. And return type after this is one way, it is coming inside. So that is parameter list is coming inside. And return type is the one that you are returning back to your main function. And what is the type? What is the data type that? So here the returning data type is double. So incoming data are x and y. X and y are incoming. They are called parameter list. And you have a function name. You have a double, that is a return type. And you have the body. And of course, you have the function name also. So initially, what do? You just have to specify only this much. That is name of the function, what is its return type, what are its parameter list. If you specify this initially, that is sufficient. After writing the main function, what you can do, you can define you can define the function. So initially specifying, you call it as declaration. Declaration of the function. So declaration, you can certainly call it as. So you have to just declare the function. That's it. So you have to declare the function, and later you can define the function. You can define the function. That is what you call it as a user defined function. So let us look into the you know more details about arguments and parameter list. So many times students, you get confused. Sir, what is the difference between parameter and what is the difference between arguments? Here is the answer. See, parameters are those values, those variables, or those list of variables that are available with the function definition. So here you call it as parameter. If the same thing, if it is there with the calling of the function. So I call the function like this. In the main, I call the function sum of 10, comma 20, 20, comma 10. So these are arguments. These are arguments. These are parameters. Parameters are available with the definition, and arguments are available with function call. This is function calling. So you are calling the function, calling the function. So calling the function is nothing but you are in your main program, you are writing the function name along with the values. So this is called function calling. So during function calling, the values are called arguments, and of course in the definition you have parameters. So this is the thing that you should never forget. The same thing it is being told in the next slide. So it is a mechanism through which the arguments are passed to the function. The variables that are enclosed within the function call are called arguments. And sometimes in some books, they are also called actual arguments. Actual arguments. And the variables that are enclosed within the function definition, during the function definitions, they are called parameters. So you have to underline, I think I told in the beginning itself, please note down important terms. So this is one important term, and this is another important term, arguments. So you can see arguments and parameters, very, very important thing. You never forget. And they are actual arguments and formal parameters. And following points you should remember while you are using these arguments and parameters. The number of arguments should be equal to number of parameters. Always remember the arguments, how much you pass, should be equal to number of parameters. This is what first thing. And second thing is the data type of arguments should be same as data type of the corresponding parameters. Very, very important. And there must be one-to-one correspondence in order to in the order of arguments. So that means how you write parameter list, same order the arguments also should be written. And same variables can be used as arguments and parameters. Yes, of course, different names or same names can be used for passing this argument list. So anyhow, this is very, very important. Please note down. I want everybody to, first day itself I told in the class, whenever you are attending my class, there will be a lot of important technical points you should note. So, and you should note all these points. Very, very important points. Right. Next, how exactly the function, overall function should be declared? Function must be declared to the program before it is called in the main. That means before it is used in the main function, it has to be declared. First, it has to be declaration. So you have to declare, you have to tell it, you have to tell the compiler that, okay, there is a function like this. declare. So after you declare, you can use. So before main function, what you do? So you declare it here. So you declare here before main function, you declare it here. Inside main function, you can call the function. You can call the function, and after the main function, you can certainly write the. You can write the definition. Definition is nothing but what is to be done inside the function. So there are three components. One is declaration. Second one is function call, calling the function. Third one is defining the function. Normally, function definition is happening after the main, declaration before the main, and function calling within the main. It will be happening. So the declaration, function call, and definition. Declaration, function call, definition. So all these three things you should never forget. And here is one example. So the declaration looks like this. Max is a name of the function, and integer, it takes two parameters and semicolon. This has to be written within, before the main function, before it is used. So that is what you should understand. Next, same. If the return type is not specified, the default function return type so is always taken. What is default return type? Default return type, if you don't specify return type in your function, so default return type is always integer. Remember one thing, the default return type is always integer, and if the function declaration specifies a return type other than int, then the return type in the function should not be omitted. And if the function returns a value, that must be exclusively written within the return statement. Of course, return statement is the last statement in the function that should return the value which is specified in the return type. What is the return type we have specified? Same type of value should return from the function to the calling function. And if you don't do it, there will be a syntax error. And of course, nested function definition is not allowed. Nested function definition. So function within one function, definition is not allowed. Of course, you can call the function, but the definition is not allowed. Each function definition should be independent. So that is one thing that you should always note down. And what are the categories of functions? There are 5 categories. You can see the first category is no argument is there, no return type. There are some arguments, but no return type. There are arguments, but one return value. There are no arguments, but return value. And there are functions with multiple return values. This is very, very interesting. And we will discuss this category 5 in detail. This entire data structure is all about this concept. So very, very important. Now, let us look into the first category. That is functions with no arguments and no return type. So here you're not passing any argument and you are not returning any argument. So it looks very straight. It looks very straight. And of course, you can see there is one example for this. You can see you're calling value. So before, observe here, before that, here what you have done function declaration. Here function calling, here function definition. So remember one thing, this is declaring the function, declaring, here function is calling the function, and here you define the function. Define the function. Define the function means you're telling the function what it has to be done. So now, value, it is not taking any argument. There is no return type. Same way, there is no argument. Void and void. Void means don't do anything, nothing. And of course, you are calling the function by just calling the name of the function, and you're not passing any arguments. As you pass, what happens? It always, what it will do, there are fixed values, period, amount, interest. It is calculating the simple interest and displaying the simple text. The same program is available in this particular link. Let me click on the link. Yeah, let me click on the link so that it opens. Meanwhile, I just clear the screen. Yeah, the same link, I just put it in the chat box for everybody. You can simultaneously work with. You can simultaneously work with. So with me. So I have pasted. I pasted along with me. You can just you can also run this program. So when you run, what happens? The function calls itself and it will display the output. So output is this one. It just displays the output. Okay. So that is one thing that you should never forget. Right. Okay. Yeah. That's the thing that you should never forget. Next, we have functions with arguments and no return type. You are passing some arguments. So some values are moving. You can see values are moving from function, that is main function, to the function. These values are moving, but no value is returning back. No value is returning back. So that concept you should understand. So this is also one type of function. So probably the same example we'll see. The same example we'll see. Look at here. Observe the definition of the function. So when you observe the definition of the function, void is there. What is the meaning of void? So no value is returned back. No value is returning back. And but you are passing arguments. P is passing, A you are passing, I you are passing, but no value is returning back. And observe now, see, integer period, amount and rate, they are all being passed here, but no return value. There is no return value here. And once these values are passed, P is passed to period, and amount is passed to A, and I rate is passed to I. And the same values A, I, and P are used to calculate simple interest, and of course same simple interest is displayed here. And the program is available in this particular link. So let us execute this program, and I'll put the same program link in your chat box so that you can also simultaneously execute along with me. Yes. So this is the second program that you can certainly execute it. And I'll just clear the screen. Yeah. Now, if I run this program, so what happens? Only the values are passed. Here, values are passed from main function to the user-defined function. So no value is returned back. So that is the concept that you should understand. Next, we have function with arguments and return type. Yes, there are some functions where you pass the arguments also, you return the arguments also, you return the values also. So here you observe here, in this example, you observe, so you are calling function 2 by passing some argument, and from function 2 some value is written, and this returning value is storing in X. Is storing in X. So that means the whatever the argument that is passing A is going to F, and finally whatever the value that is E returning, it is coming to X. So There are arguments also, there are returning values also. So let us look at those example in the next slide. Here you can see float value, integer p, a and I. P, a, I are parameters, and float is your return type. That means the function value should return float value. And observe here, you see these are all the variables: period, amount, interest, interest rate. I'm passing it, and after passing it, the values will come here. Will P will hold period value, A will hold amount value, I will hold I rate value, and after doing all these calculations, what happens? Returning the value temp. So whatever return value that is returning from this function, it is going and storing in SI. That's why you write SI is equal to value of so and so. And finally, this SI value you are displaying here. You're displaying here. This is the program. And here there is arguments passed, and also return value also it is written. So same program is executed in this particular link. You can just have a look at it. So meanwhile, I just clear the screen and I copy the same link in your chat box so that you can also simultaneously work with me. Yes. So look at here, float is the returning value and you're displaying. That's why since SI is a float, I'm using percentage %F for printing SI. So just run it and you can see the code. You can see the code. Yes. Code is being executed and result you got. So this is the one. So that's about arguments and return value. Next is recursion function, which calls itself. You call it as recursive functions or recursion. So this is one of the very important type of function in which the function will call itself, and this recursive functions will solve complex problems, will make complex problems into very simple problem. And of course, you can see recursive functions are those functions that will have the same name and they call itself. And as I said, a recursive function should follow two properties. The first property is the function must have stopping condition. That is, it should not continue to call indefinitely. There should be some condition for stopping. And each time the function is calling itself, it must be in recursive form. That is, it must be nearer to the solution. And the advantage of recursion is recursive function reduces the complexity of the problem. Recursion allows user to write much smaller programs. So the complex program is written in a smaller way, and recursion is implemented at multiple number of nested levels. So this is a top-down programming approach. Top-down programming approach, you'll understand with an example. I'll explain. So what is exactly top-down? How exactly it is working? So whenever you call the function by itself recursively, repeatedly, what happens? Each time when you call, so it make use of a data structure called stack. So it will make a use of a data structure stack. So what happens? First time function is called, it will be pushed to the stack. Second time, yes, it will be pushed. Third time, it will be pushed. Like this, it will create a pile of function calls, and finally when the result of the top is you have got, so what happens, it will come back to the bottom, it will come back to the bottom, it will come back to the bottom, and finally the bottommost will give you the result. So this is called top to bottom, top down approach. This is called top down approach. Of course, we'll discuss this. We'll discuss this with a simple example. Let us look at, I want to find a factorial of a number. Okay, factorial of a number you know very well. If you are calculating factorial of n, it will be 1 if n is equal to 0. Exactly, if n value is 0. If it is more than 0, then it is nothing but the number and its previous values factorial is what factorial of 5 is all about. 5 factorial is nothing but 5 into 4 factorial. 4 factorial is, so it is recursively calling. So 5 factorial is calling another factorial with the 4, and 4 factorial is calling 3 factorial. Again, it is recursively calling. So what happens? It will create a stack. So it will create a stack like this. So it will write 5 into 4 factorial. 5 into 4 factorial it will write, and it will call the next function. That is 4 into 3 factorial it will call again, and 3 factorial again it is 3 into 2 factorial, so it will call same way. 2 factorial is nothing but 2 into 1 factorial, so it is 1 factorial you can certainly think of, and 1 factorial is nothing but 1 into 0 factorial. You know very well what is a 0. If n is equal to 0, factorial is nothing but 1. So 0 factorial is 1. So what happens? This 0 factorial is replaced by 1. It is replaced. It is going to replace by 1. And so this 0 factorial is replaced by 1. So now 1 into 1 is 1 only. And the 1 factorial is replaced by this answer. So this answer is replaced by 1 factorial, that is 1 into 1 is 1 factorial. It is replaced by 2 factorial, of course. So here in 2 factorial, 2 into 1 factorial, it is replaced here. 2 into 1 is 2. So this 2 is replaced at this position, that is 2 factorial. So this 2 is, replaced here. And 2 into 3, that is 6. 6 is replaced by 3 factorial. So, and that is 6 into 4. 6 into 4 is 24. 24 is replaced in 4 factorial, and 5 into 24 is 120. 120 is the final answer that is going to be returned back. You can see from top, it is returning values, is checking the values, it is calculating the values and returning back. Top bottom approach, this top to bottom approach. So this is happening using a data structure. You call it as a stack. This data structure, you call it as a stack. So using stack, this recursion is going to happen. So that is the concept, how exactly recursion works. Now, the same program is explained, is executed here. Look at here. So you call it as multiply numbers, or it is a factorial. So integer n is the integer. If you pass that, so it will give you the final long integer is the returning value, and name of the function is multiply numbers. So you are taking a number n, say for example I have given 5, so it is calling the multiply number 5. So what happens? 5 moves here, And if it is greater than 1, then what it is doing, n into, that is multiply number, that is factorial of n minus 1. So that means you are recursively calling this function. So what happens when you recursively call, the stack piles up, and once n becomes exactly 1, it is returning 1. And of course, the top down approach, whatever you have visualized, it happens back here. And finally, the returning value, whatever the final value will be there, so that will be returned, and that returning value is directly printed in the printf statement. The same program is available in this particular link. You can certainly look into this link. I'll copy the same link, and those who have not yet typed your USN, please, with this USN only, I could able to track your attendance. It is mandatory that please you type in your USN if you have missed. Okay. Yesterday also there were around 53 students, and only 29-30 students have given your USN. So only those people, those who have typed the USN, will get the attendance. And obviously the system will mark absent. The system will mark absent if you don't type your USN. And the same thing I'll be reporting to the department, your department. And you know, now look at this example. In this example, I pass 5 as my input here. 5 is the input that I am passing. Now, as soon as I run this code, so what happens? So recursively, 5 into 4 into 3 into 2 into 1. So 120 is the answer that I am getting. 120 is the answer that I am getting. So that's all for today's class. Next class, we'll talk about arrays. So thank you. All class resources are available in this website, all videos, all notes, everything. Meanwhile, type in your USN for the attendance sake. Thank you. If you have any doubts, you can call me. I'm there in your WhatsApp group, or you can mail me. Anything is okay. But keep learning. It is one of the very important subject. Here afterwards, tomorrow we'll talk about functions. Today functions over, arrays and structure unions. Later, from Monday onwards, we'll start the actual data structure, that is